Hi guys, in this video what we're going to do is figure out what the limit is as x approaches 0 of tangent of x minus x divided by x minus sine of x using L'Hopital's rule. L'Hopital's rule basically says that if you have a limit of the following form, and f and g are both differentiable at c, and the limits of indeterminate form 0 over 0 are plus or minus infinity divided by plus or minus infinity, then this limit's equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x. And you can apply this rule indefinitely as long as these conditions are satisfied. So now notice that in the numerator here, if we were to just go ahead and let x equal 0, we would have tangent of 0 minus 0, which is just equal to 0, and in the denominator we would have 0 minus sine of 0, which is also just equal to 0. So we can go ahead and apply L'Hopital's rule to this problem right here. We're going to have the limit as x approaches 0 of secant squared of x minus 1 divided by 1 minus cosine of x. So all we've done is taken the derivative of the numerator and the derivative of the denominator. Now let's go ahead and plug in x is equal to 0 and see what we have. We have secant squared of 0 minus 1, and this is just equal to 1 minus 1, and that's equal to 0. And in the denominator we have 1 minus cosine of 0, which is just equal to 1 minus 1, which is again equal to 0. So we have a limit of the form 0 over 0, and that means that we're going to have to apply L'Hopital's rule for a second time. Doing so gives us the limit as x approaches 0. Now the derivative of secant squared of x is just 2 multiplied by secant squared of x times tangent of x, and the derivative of 1 minus cosine of x is just equal to sine of x. Now tangent of 0 is just equal to 0, so in the numerator we have 0 because anything multiplied by 0 is just equal to 0, and sine of 0 is just equal to 0. So we're actually going to have to apply L'Hopital's rule for a third time in order to solve this problem. Doing so, we have the limit as x approaches 0. Now we're going to have to use the product rule to take the derivative of the numerator. Doing so, we have 2 multiplied by secant squared of x multiplied by secant squared of x plus 2 times secant squared of x times tangent of x times tangent of x divided by cosine of x. Now if we plug in x is equal to 0, in the numerator we have 2 times secant to the 4th power of 0 plus 0, as tangent of 0 is just equal to 0, and in the denominator we have cosine of 0. Secant to the 4th power of 0 is just equal to 1, and cosine of 0 is equal to 1, so we're just left with 2, and that's the final answer to this problem. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe. I hope you have a great day.